My next speaker is already with me. I would like to introduce Oliver. Oliver from Visionary AI. Perfect, your t-shirt.
I'm on brand.
Perfect. And Oliver is going to talk about Cut the Noise, solving image signal processor performance with AI.
Okay.
So the floor is yours.
Thank you very much. So is this the clicker, by the way? How's that work?
You just click here.
OK, gotcha, right. OK, we're Visionary AI, and we are an Israeli-based startup founded in December 2020. We're pretty new, but we are already in revenue. And the tech industry is very engaged in what we're doing because we are solving a problem which a lot of the big tech companies of the world are worried about and concerned about and have not found a solution to. And our solution is going to be, it's both for consumer products and for machine vision type products, but the first ones to hit the market will be in January 2020 in a mass-produced consumer product. What we do is that we use AI to remove the noise from image signals. And we also have a software-based image signal processor. But it's the first one that I'm mostly going to be talking to you about today. And we're in a number of different sectors. So what we have to show you is obviously applicable to consumer devices like laptops, webcams, and mobile phones. But we see it, and we have a lot of interest from security cameras, automotive, drones, and medical, anywhere where you cannot control the lighting. So if you're in a factory where you have great lighting and it's perfectly controlled, you don't need us, but everybody else probably does. And the problem that we're addressing is that of noise. This image that we have here is probably the worst image that anybody's showing here at this show. This is a close-up of a number plate, a license plate, taken at night on a moving car in a smart city application. And on that piece of number plate, license plate, only a very few photons will be bouncing off that area. And into the lens of the camera and onto each pixel. And honestly, there's not really enough to do high-quality recognition in that kind of case. So when light is low, noise is a problem. It's worse when it gets hot because of there's some thermal effects that create noise. And it's a problem for machine vision, and it's a problem for consumers as well. Just to show you where we fit in the process, we don't do the perception. We are after the sensor and before humans or machine vision does perception. And the output signal of the sensor is normally between 12 and 20 bits. It can be higher, it can be lower. And there's a component called an image signal processor that resolves the image, processes it, makes it, demosaics it, and makes it fit for human consumption. But in that process, it compresses the data. And we realized that in the process of compressing the data, image signal processors do not make good decisions about which information is kept and which information is lost. So we have a different approach. So we have implemented our image signal processor as a software component, and we've tied that very closely to an AI-based denoiser. So we have trained a neural network to identify what is noise and what is signal, and to take out the noise. Before compressing it and outputting an 8-bit signal as you would normally have. What that means, going back to our license plate example, is that we can strip a large part of the noise, and even in this application, which is at night and less than moonlight, in a moving car, you can still get an image that is readable very easily by humans or by machines. Here's another example. This is a tram. And you can see that in the denoised version, because we have taken the noise out, we can increase the gain of the system and make it more sensitive. And by that, you can recognize more objects, and you can increase the accuracy of recognition. And my last example here is these are two of our colleagues playing in the desert. These are both the same photo, by the way, from the same camera. And you'll just see a slight shadow on this. That is the same two people playing in the desert. We've denoised it and increased the gain, and you'll see that this is effectively a true night scene. I'm not sure the video will play. It might play, yes. And just to give you an idea, this is a real-time process. This is not something that we do on static images. And just to give you an idea of how dark this was, you'll see just under the eye in our name there's a star, and there's one in this corner as well. So this is truly taken at night with an ordinary camera. It's not some special night vision camera. This is an ordinary camera. In terms of technical numbers, so people have been using AI to get rid of noise for some time, but they have not managed to do it in real time using sensible amounts of compute that you can have in an ordinary device. And to compare like for like with a algorithm that gets similar performance to us, it takes over 200 times longer. We've made a denoiser that is small enough, that is light enough to fit in low cost, low power consumption consumer and professional devices with a sensible size of and power of processing. And that's where the innovation really comes. And so we combine our denoiser with our image signal processor, and on that we are building. We're able to build all sorts of extra features that the industry will need. It's a solid foundation for vision features. Thank you very much.
Thank you, Oliver. Let's go from Visionary AI. Questions?
Thank you for the presentation.
Thank you.
What do you sell? Do you sell IP? Do you sell a product? What is it? Is it an SDK?
Yeah, we sell IP. We are an AI company that sell IP, so we will work with OEMs and with semiconductor manufacturers, and on a license and royalty basis.
And all the military guys are lining up at you.
Security is an application, and people are speaking to us, but we are selective about our engagements. And honestly, that's not our focus. That's not where we see the biggest opportunity, and that's not where we see, that's not where we want to take ourselves.
Thank you.
Thank you. Further questions? I don't see any. So I would say, okay. Oliver, thank you very much for giving your presentation on how to cut the noise with Visionary AI. Thank you.